Welcome back to the another session of our data structure journey. Today we are going to cover how to evaluate the postfix expression. Last class we are already cover how to convert the infix to postfix, how to implement in C language also. Then we have to understand how the postfix is go for evaluation by using the stack. This is one type of stack application. So first we have to know what is the reason, because whenever any expression written in the postfix expression, it can be evaluated very faster way compared to infix notation, as there is no parenthesis present inside the postfix expression. We are already cover infix to postfix, and we already found whenever we are converting infix to postfix, there is no parenthesis. As there is no parenthesis, that's why the execution time is or evaluation time is very faster compared to the infix. That's why we are using the postfix expression for the evaluation. So next one, what is the algorithm? How we have to perform the postfix evaluation? So first we have to read the postfix expression, which is converted from the infix expression from left to right. If operand encountered, then we have to push into the stack. If the operand operator uncounted, pop two element from the stack, and we have to make A as a top of the element, B is the next to the top of element. Then we have to evaluate and push into the stacks. When we reach the end of the post fixed string, then what happened? We have to pop the result from the stack. So this is the algorithm we have to follow for the evaluation. So let us take an example. So example is 4, 5. One thing we have to remember here, all the digits are single digit. 7, 2, plus minus multiplication. So we have to read the post expression or string from left to right. So we have to scan from this one. So for example, this is our stack. So this is the push operation. This is pop operation. So if we are encountered any operand, we have to push into the stack. So first one is the 4. So 4 is a operand. So we have to put into the stack. Then again, next one is the 5, push into, then 7, we have to push into, then also 2. So we have to push. So right now our stack consists of 4 elements. Top is the this element, 2 is the top element. If operand encountered means this one right now. So whenever plus operator is encountered, then what we have to do? Pop two element from the stack. So we have to pop two element. So A is the top of the element. So top element means 2. B is the next top. So we pop two element from the stack. So right now our stack and top points to. So this one the top right now we have to pop two element. Then evaluate B operator A. B operator A means B plus A. So it equal to 7 plus 2, that is 9. And push onto the stack. So again we have to push the 9. So you have to push. So whenever we push, then at that time what happened? Pop points to 9 right now. Anyhow, we have to read from left to right. So next one is minus. So whenever any operator encountered, pop two elements. A is the topmost, so we have to pop two elements. So A equal to 9, B equal to 5. So we have to pop two elements. So whenever we pop two elements, then what happened? This is our stack. Now top points to this element. After that pop, we have to evaluate B operator A. What is the operator right now? That is minus. So B minus A means 5 minus 9. What is the value? 4. 4. After that, evaluate B operator A and push onto the stack. So we have to push the minus 4. So we have to push the minus 4. Once we push the minus 4, then what happened? After push, what happened? Top points to the topmost element. Then, as we have to read from left to right, next value is star. So right now, if the operator encounter, right now the operator is encountered, then what happened? If we get the operator, then we have to pop two elements. So top element is minus 4, next top is 4. Result is B multiplication A. So what is the value? 4 into minus 4. So it is minus 16. Whatever result, push onto the stack, evaluate the operator and push onto the stack. So once evaluation is done, we have to push into the stack. So we have to push into the stacks. So after the top of two elements, what happened? We have to push into minus 16. So now what happened? And we reach, when reach end of the postfix, then what we have to do? We have to pop the result from the stack. So we have to pop the result. So now we have to pop the result means minus 16. So our result is minus 16. So if we are going to evaluate this thing, so we will get the result that is the minus 16. Let us take another example. So here our string is 3, 4 plus 2 multiplication 7 division. So this is our postfix expression notation we have to evaluate. So this is our stack. So what is the algorithm? Read the postfix in left to right. So we have to read. So first we read 3. If the operand, 3 is the operand, then what we have to do? We have to push into the stack. 3. Next, operand. If operand, we have to push it. So if it is a operator, now we have got the operator is plus. If the operator, then we have to pop two elements. So two element means right now top points to this value. So right now what we have to do? We have to pop two elements. So we have to two elements. Topmost is A. Next to topmost element is 3. So once we pop the value, then what happened? Our stack is empty. That time top points to minus 1. This is minus 1. This is 0. This is 1 as per our indexing. 2, 3, 4. Then A is top element, B is the next top element. Then evaluate B operator A and push the result onto the stack. So B plus A we have to, because we got the plus operator. So 3 plus 4, that is 7. So what? Result into the stack. So now we have to push the result into the stacks. Once we push the value, then what happened? Top points to this value, that is the 0, 1. Then next one is 7. So whenever any operand, we have to push into the stack. So we push 2 into the stack 2. Then operator. So whenever any operator, then what we have to do? We have to pop 2 element. So 2 element means so A is 2, B is 7. Then once we pop the value, then what happened? Again pop points to, there is no value. So now pop points to this value at the -1. Then B, here evaluate B operator A. B operator A means B multiplication A. B multiplication A means 7 into 2, that is 14. So 14 we have to push the result onto the stack. So we have to put the value here. Once we put the value, then pointer points to this value. Then next one is 7. So whenever any operand, we have to push. Here it is mentioned, if operand encounter push onto the stack, so 7. Then next one is the operator. Operator is 7. If the operator is encountered, pop 2 elements, so A equal to 7, B equal to 14. What we have to do perform? B operator A, so 14 divided by 2, 7, its value is 2. So whatever result is encountered in the result set, so what we have to, this value already we have already taken. So after that, what happened? This is the, so it is 0 index, store the value of 2. When reach the end of the postfix, so right now end, this is the end of the string. So what we have to do? We have to pop the result. So what is the result? Result is 2 value. So we have to pop the value and we will get the result is 2. So this is our postfix expression and this is our result value. So this is the way we can able to evaluate postfix expression. Main reason is that postfix expression, there is no parenthesis. So the execution time is very fast compared to the infix. So whenever we write any expression, so for the computer, what it did, first it convert infix to postfix, then it go for the postfix evaluation. So total 2 stack we required, 1 stack we required for infix to postfix, then we required to evaluate the another, evaluate the postfix, we require another stack. So total 2 stacks we require for any evaluation of any arithmetic expression that is written in the infix. So we can go for another example. Let's take another example. 5, 7 plus 6, 2 minus multiplication. For example, this is our postfix string is given. We have type that the operand. So this is our stack. We have to store the first 5. Second one is operand. Operand means 7. We have to store the 7. So whenever any operator, so next one is the operator, then what we have to do? We have to pop to value. So we have to pop to value and store the topmost element 7. B is the next to the topmost element. So now what happened? No element present inside the stack. If no element is present inside the stack, then at that time we are already evaluate this value. So we have to go for evaluation. Operator is plus operator, then this is A. Means 5 plus 7, this is the value is 12. Whatever result we have to put into the stack. So we put into the stacks. Next one is 6. So whenever we encountered any operand, simple we have to put into the stack. If any operator, then we have to go for pop operation. So next one is 2. Simple 2. Then minus. So whenever any operator, we have to pop 2 element. A is topmost element, B is the next to the topmost element. Then what operation we have to perform? We have to perform the B operator A. B operator A means B minus A, that is 6 minus 2, that is 4. Whatever result we have to put into the stack. This is the algorithm. Then next one we have to read, that is the multiplication. So whenever we encounter a multiplication, again we have to pop two element. Operator is multiplication. A is 4, B is 12. What we have to do? B multiplication 4. It means 12 into 4. So whatever result we have to put into the stack. So what is the result? Result is 48. So after that we have to put into the evaluate the operator push into when reach. So after that we are already reach. Pop the result from the stack. What? So we have to pop this value. So which value? That is the value is 48. So this is the our resultant value, that is the 48. So remember here whenever we go for evaluation, B operator A, never do the A operator B. As per the rule, we have to evaluate B operator A, not the A operator B. So this is the things we have to remember whenever we are going to perform evaluation of any string. So certain things we have to remember. And what is the need? Need is the execution time is faster. That's why we are going to perform the infix to postfix, then postfix to postfix evaluation. For both the operation, total 2 stack we require. Hope you are able to understand the concept of postfix evaluation. Thanks for watching the video.